Next one is the phenomenon called Tyndall effect. What is Tyndall effect? Scattering of light by colloidal particle or particle in its path is called Tyndall effect, that we are going to see it in detail. Consider a beaker containing true solution. True solution means a solution containing salt solution, sugar solution, or example of true solution, that is optical clear solution. So from the light source we are passing light through the true solution and observing the light perpendicular to the source, perpendicular to the path of the light. We are observing the path of the light. For the true solution, the path looks very dark, means the true solution not scatters light, thereby it looks dark. The same light when passed through colloidal solution like dust particle or milk or any other colloidal solution, here the path of the light is visible when perpendicular to the direction of the light. Why in the case of colloidal solution the path of the light is visible is the colloidal particle scatters light, thereby the path of the light is visible. So what is Tyndall effect is the scattering of light by particle on its path is called Tyndall effect. Scattering of light by particles on its path or solution is called Tyndall effect. So all solutions are not scatters light, especially true solutions are not scatters light. Colloidal solutions are scatters light. The example of Tyndall effect is the projector in a cinema theatre or cinema hall. The light comes from the projector and falls on the screen. On the path of the screen we can see the movement of particles. Why the path of the light is visible to us is the particles, dust particles scatters light, the dust particles scatters light, thereby the light is visible to us. The light comes from the projector, visible to us as the dust particle scatters light. So best example of Tyndall effect is the light comes from the projector in cinema hall. And in the early morning or in the evening, the sunlight emerges from our window slit. From the window slit, we can see the Tyndall effect, the particles, the speed movement of particle in the sunlight. The dust particle, the air particle, fog, particle present in the fog scatters sunlight, thereby we can see the falling of sunlight from our window slit. And also the sunlight in the dense forest in the early morning, from the dense forest among the trees we can see the slit of sunlight in between the trees. The fog and dust particles scatters light, thereby we can see that light. So Tyndall effect is light comes in cinema theatre, emerging of sunlight in window slit, light emerges in dense forest, the scatters of light by sunlight by particles called Tyndall effect. Why and how the sky appears blue? The atmospheric air scatters blue light, thereby it appears blue. In the sunlight, atmospheric air scatters blue light, thereby it appears blue. The sunlight consists of two components, longer wavelength and the shorter wavelength. The longer wavelength is red light, red, orange, yellow. The shorter wavelength consists of white and blue light. The scatter blue light, that is the shorter wavelength light, thereby the scattered blue light appears in the atmosphere, thereby the atmospheric, the sky appears blue. Atmospheric air scatters blue. And another question is, the direct sunlight coming through blue sky still appears to be white. Why? The direct sunlight coming through blue sky, direct sunlight coming through blue sky still appears to be white. Why? The unscattered blue light, the composition of the sunlight. Because of the unscattered blue light in the direct sunlight, in the white light, the short waved white light, it appears to be white.